quick lesson here on solving proportions. Okay, this is a very useful skill. I think you've done it before. And a proportion is when you have two ratios or two fractions that are equal to each other. And this comes up quite frequently, especially in this current unit where we're talking about ratios and rates. So the key to solving a proportion, and again, a proportion is, like you see up here, A, B over B equals C over D. Okay, two fractions that are, or two ratios that are equal to each other. Well, the key to solving them is to use cross products. So if you cross multiply in a proportion, the cross products are equal. That's the numerator of one times the denominator of the other side. And if you do that, sometimes called the butterfly method. Okay, so if you look here, you multiply these two numbers together, this 2 and 2, and these two numbers together here, and those cross products are equal. Okay, so this is a key characteristic of proportions. And normally when you have this to solve problems, 3 of these numbers in the proportion you're going to know, and one of them will be an unknown or a variable. And so you can use this cross multiplication or cross product method to solve a proportion. So here's an example of how it works. Okay, so we're solving equations here. There's going to be an unknown as a variable. It's going to be in some place somewhere in the proportion. In this case, B over 15 equals 66 over 90. And again, you multiply across. So you do B times 90 and 15 times 66. Okay, so if you can do this in your head, this multiplication, then a lot of times you'll just skip this step of writing it out. I'll always write 90B. I will not write B times 90 like that. I'll always write it like this. In the first step, 90B. And sometimes you'll write 15 times 66. Sometimes you can just put in your calc. If you can do it in your head, then you can skip that step. Okay. And then now this equation now, 90B equals 990, is a one-step multiplication equation. So we solve that by dividing by this 90 to undo this multiplication. So you divide both sides of the equation by 90. That's good algebraic equation solving skill, which we will talk about much more later on. You've already done this last year a little bit anyway. And so the answer then, these 90s cancel each other out. 90 divided by 90 is 1, and B equals 11 in this case. Example B here, 3.2 times 36, again, using your butterfly method. 3.2 times 36 equals 9 times n, okay? And 3.2 times 36 is 115.2. Use your calculator for that. Divide both sides by 9. You do not have to rewrite this line again like that. You can just put the divided by 9 under here. You'll see on my example on the next problem. Divide both sides by 9. So again, these 9s cancel each other out. That equals 1. And 115.2 divided by 9 is 12.8. So your answer is n equals 12.8. It talks here that you solve this. You can sometimes solve these mentally. These are really equivalent fractions. And so if it's easy to get the equivalent fraction, then you can sort of skip these proportion cross multiplying steps and just write the answer down. And for accelerated class, that's an acceptable thing to do. Like here, if you recognize that 9 times, well, not so easy to do this one in your head. Okay, this one was easier, that 15 times 6 equals 90, right? So B times 6 has to equal 66, so B has to be 11. So it's an equivalent fraction thing that sometimes the answers are so easy that you can do that. Try not to give you too many of those, though, because they're not making you solve proportions using cross products. So here's how I show the work. So in 1A, instead of having you do it here, I'm pointing out this is how I show the work for these types of problems. Okay, so the cross products, 20 times x and 4 times 7, that means that 20x equals 28. 4 times 7 is 28. Divide both sides by 20. These cancel out. 28 divided by 20 is 1.4. So that's what your work should look like. You could x equals 1.4 is your solution. Your solutions, when you're solving equations like this, should always include the variable equals, right? So we have seen this before. We've done some equation solving before. So x equals 1.4 for letter A. 1B is one that you really should be able to do with equivalent fractions and do in your head. Right? 7 over 14 equals what over 12? You should all be able to do that one in your head. Since 7 is half of 14, C has to be half of 12. So the answer is 6. If you were going to do this by cross multiplying, 7 times 12, which is 84, equals 14 times C. And 84 divided by 14 is 6. Either way. But this one is so simple, you really wouldn't be expected to do work for that one. Not so much here for a 1C. What is the cross product here for 1C? 34T equals 6.8 times 50, which is 340. So if 340 equals 34T, divide both sides by 34, and X, or T rather, equals 10. T equals 10. And lastly, not going to do this one in your head either. Cross multiply, 51M equals 8.5 times 42. Doesn't matter what side you put these on, right, or what order they're in. Divide both sides by 51, and M equals 7. Okay, so that's solving proportions. So that's the skill. Now let's apply this in real-world problems. The wait time for a roller coaster is 20 minutes when there's 160 people in the line. How long, if the rate stays the same, how long will it take if there's 220 people in the line? So for real-world problems, it's like all times that we're going to use algebraic methods for solving real-world problems, we have to define a variable to represent the unknown quantity. Okay, and in this case, the unknown quantity is the wait time. Oh, they use W here. And instead of defining the variables, like if you were going to write the equation here and you say W equals the wait time in minutes, right? It's acceptable for me, if you're going to write a proportion, to define the variables by writing the units of the top and the bottoms of the variable, or the top and the bottoms of the ratios on the side. The key to these problems is making sure that you write the same numbers on the top of both sides of the equation. Okay, so I like to do this saying, well, this one's going to be minutes over people, and then the other side also has to be minutes over people. So I know it's 20 minutes over 160 people, and on the right side, it's I don't know how many minutes. I'll use variable W over 220 people. So minutes over people equals minutes over people. The most common mistake is to have these flipped on one side, and then you'll get a wrong answer. You could just as easily write people over minutes equals people over minutes, okay? But you have to make sure that they match up on both sides of the proportion. Then cross multiply like they show over here in the book and divide both sides by 160. You get 27.5, real world problem. So you're going to put a word in your answer. The answer is 27.5 minutes. Wait time for 220 people. All right, here's a got it problem, a real world problem for you to do. Alicia's class is making care packages for a local shelter. They can make 8 care packages with 240 food items. Well, how many care packages can they make with 500 food items? So we're going to start by setting up the proportion. Care packages over food equals care packages over food. So packages over items, 8 over 240 equals P packages over 500 items of food. So here's my, this counts as definition of the variable. If you want, you could say P equals packages someplace else and not write these out like this. But this also helps you make sure that your two ratios are organized properly. To solve this, you might want to do this one in your head, but it's not quite so easy. So I'm going to cross multiply. So 8 times 500 equals 240 times P. And 8 times 500 is 4,000. Because 2 times 500 is 1,000. Divide both sides by 240. Make sure you write the division step here. It's good algebra. You need to get used to that. And so 4,000 divided by 240 is 16.66666, also known as 16 2/3. So the question then is, how many care packages can they make? I answered that they could make 16 care packages. You're really 16 2/3 care packages, but if the care packages required that many pieces of food, then you can make 16 complete ones. All right, so some of you might say, well, isn't it just as easy if you did 240 divided by 8 and got, sort of a unit rate for, or 8 divided by 240 in this case, for how many, care packages per food item or food items per care package, and then just multiply. And that is the case with all proportions that you could use. Go to the next page here. You could use the constant of proportionality. This is page 220. The constant of proportionality, or the unit rate, okay, just as easily, okay? And really, this method for unit prices is more convenient, really. If you're going to have to calculate something more than once, like they give you the ratio for one thing, and then they say, well, what is it for this and this and this and this, and you have to use multiple times, then this method is better, okay? So the example here, and you'll see the examples they use in this are going to be money, because that you really do use constant of proportionality, or the unit rate, unit price when you're paying for various things. So Mrs. Hidalgo paid $30 for 4 students to visit the museum. What is the cost for 20 students? Okay, now you could set this up as a proportion. Dollars over students equals dollar over students. But it's really pretty convenient to say, well, what's the dollars per student? And then multiply that times 20. So that's what they're talking about here. You find the constant of proportionality, also known as the unit cost, dollars per student. 30 divided by 4 is $7.50. Okay, so if you're looking for 20 students, then you do $7.50 times 20, and you get your answer. Now, the book here writes an equation right out off the bat here, and since they don't tell you to write the equation, I wouldn't really expect you to do this unless they said write an equation. Okay, so if you didn't have to write an equation, you just, once you find the unit price, you multiply by 20 to get your answer. This step right here. Okay, but they are talking about, using the equation like we did in the previous topic, where we calculated the constant of proportionality and wrote an equation. So it's kind of the same thing. If you are going to write the equation, you have to define your variables. They messed up here and didn't write dollars again for cost, right? Cost is in dollars when you define your variable. So if C is the cost and S is the number of students, then your equation C equals 7.5 or 750 S, since you already calculated the constant of proportionality, and then you substitute in 20 for S. So you can see why, if you were going to do, well, how much is it for 50 students or how much is it for 100 students, that this method would be easier, because you can just keep plugging in the number of students and calculate your answer. The answer, by the way, the final answer for this problem is $150. Make sure you specify your final answer. Okay. Now you could do this again as a proportion. They set it up down here. Students, cost over students equals cost over students. Okay. You could also do students over students equals cost over cost, but it's harder to keep track of those and not mess them up. I would not use a proportion for this problem. I think a unit rate or the constant of proportionality is quicker and easier. Okay, and I go back and forth because the 7th grade book calls this using the unit rate. Okay, and the unit rate and the constant of proportionality are the same thing. Right? They are the exact same number, the same concept. So this is also known as using the unit rate. All right, so let's take a look at an example here. So Matthew paid $49.45 for 5 DVDs. How much would it cost for 11 DVDs at the same rate? Okay, so I would again calculate the unit rate or constant of proportionality for this problem. That's dollars per DVD. So $49.45 divided by 5. That comes out to $9.89 per DVD. So how many for 11 then? Just multiply 989 times 11 to get $108.79. Again, if you wanted to write an equation for this problem, define your two variables, the two changing quantities, cost in dollars and the number of DVDs, and write your equation. Now, you could still solve this one using a proportion. Dollars over DVDs equals dollars over DVDs. And if you did this cross multiplication and then divided, you would end up with this same price again, $108.79. All right, so that's the basics of solving proportions. I think just practicing these will get you there, and maybe there'll be a little bit of extra help for folks who need some extra review. But cross multiply and then divide both sides to get your answer when you are solving the proportion, or you can use the constant of proportionality or unit rate method as an alternate way to solve problems using proportions and proportional relationships.